let's go with the fourth question, which is, it has to do with pair merge. So pair merge is taken to be more complex than simplest merge. Thus, it seems to be an apparent departure from the strong minimalist thesis. What properties do the phenomena that pair merge has been said to be related to or to capture? I can think of adjuncts, some aspects of morphology according to different authors. And also, it seems to me in your recent talks that you have been assuming that it may also be used to handle unstructured coordination. Why? So if that's the operation that we are going to use to handle those phenomena, what do they have in common?
Well, let's start with unstructured coordination. Now, that's been a problem for 60 years. There simply are structures in language. It's just a fact, like John, Bill, Mary, the guy I met yesterday, Tom Smith, ran, danced, sang, so on and so forth. I mean, that's language. These sequences like John, Bill, Mary, the guy I met yesterday, they don't have any internal structure. But they're unbounded. They're unbounded and they're unstructured. Now, that was a problem 60 years ago because you can't generate them by any form of phrase structure grammar, any rewriting systems, even universal rewriting systems, which are basically universal Turing machines. Can't do it. You need an infinite number of rules. It was thought for a while you could do it with generalized transformations, but that was shown to be wrong by Howard Lasnik. So you couldn't generate them by any means. And that remains true right now. No means that anyone has proposed to give you unstructured, unbounded coordination. So it's a problem. Well, notice that these things have to be sequences, not sets. The order matters. So if you say John and Mary ran and danced respectively, the order matters. If you say in that order, the order matters. And there are other such devices. So these things are unstructured sequences, which means that we need an operation in language which says form a sequence. Take a set of objects, form a sequence out of them. Okay, that's an irreducible fact about language. Well, if you have sequences, then the smallest sequence is of course 2 elements, but that's a pair. So you automatically have pairs. And if the pairs are used for merge, you have pair merge. So it's there. Question, is it used for anything? Well, that's an interesting question. I think that's on the drawing boards. There are things that look like pair merge ought to be appropriate. Actually, one of them is adjunction. So if you have a phrase, young man, it's understood to have the properties of man, not of young. Okay, that's just a fact. That suggests strongly that young is adjoined to man, and that the operations of composition aren't looking at the thing that's joined. It's kind of like a separate dimension. Now, there's no reason to think that the brain has 2 dimensions just because paper does. When we write these things out, it's 2-dimensional, but doesn't tell us anything about the brain. It may have multiple dimensions. So it could be that things are just tacked on in a certain place. That could enter into interpretation. Like when all this is interpreted semantically, the adjuncts are interpreted as properties of the thing they're joined to rather than conversely. So that looks like a domain in which an asymmetrical relation might be appropriate. In morphology, well, if you look at the internal to the structure of lexical items. There's a lot of computation going on. And some of these also seem to be asymmetrical. So they may involve something like pair merge. But I think that's just an open area of research. Weirdly, this operation is there basically because it's the minimal case of sequences, and we can't avoid sequences. So the question is it used anywhere? I think that's pretty much an open question.
Okay, thank you. I mean, there are many questions that come to my mind from this response, but we can maybe over the email discuss details because there are many things there.